So welcome back. We have covered a lot of ground in this YOLO tutorial. We have made the model. In chapter 1 we talk about our model, which is our AI expert. In our chapter 2 we talk about our study material or our data set. Next in chapter 3 we talk about our toolbox, which is also known as utilities. Later we talk about the configuration or the rule book. And in chapter 5 we talk about the predictor, which is the engine that applies the model. And we talk about the validator in chapter 6, which is nothing but a judge of the performance. And in the previous chapter or the chapter 7 we talk about the trainer, which is the coach for learning. So in chapter 5 predictor, we saw how to use this model.predict or simply model to get the AI expert to look at new image or video. If you have not seen that, you can see from the playlist. So when you do this, or when we look at the image or video, the model does not just print things to the screen. It gives you back a structured object containing everything it found. The object is this object is called the results. So imagine you have asked your AI expert or your model to look at the picture of a street and find all the cars and people. After processing the image, the expert needs to give you a report of his findings. The results abstraction in the YOLO is exactly this report. So it is a special object that neatly packages all the output generated by the model after it has made the prediction. So instead of just getting raw numbers, you get a friendly container that holds different types of findings. So depending on what the model was trained to do. So when you run like a results section, which we'll be discussing later, this variable results variable will hold the result object and or a list of them, and if you process multiple images or video, it will cover the list of them, otherwise it will obtain or it will carry the result. So let's discuss on that. So when you run this function model path, the variable just hold this result object or a list of them. So for example, there can be different results. Okay, so one is a bounding box. If you see here, so this is the bounding box. If it is an object detection model, so for example it is detecting the signpost, it will tell you where it found. So where the object is found by giving the coordinate of for the boxes around them. So the coordinate is given here. You can see the centroid as well as the height and width, which means basically it is giving the box we talked in our previous videos as well. Next is the segmentation max. For this is for the detection, but for the segmentation it will give the pixel level outlines around the objects. So for example, it is separating our horse. Next, output can be the key point. For example, if it is a pose estimation model, so for example if you are doing yoga or if you are doing something like that, it will give you the location of specific points on objects, like the joints on a person as shown in this figure. Next is the class probabilities. For example, we can see in this figure there is a bounding box as well as there is the probability. So for example, this box is showing airplane and saying that probably the probability of this being an airplane is 87% or 0.87. So if it is a classification model, then it will tell you the likelihood of that image belongs to each possible category. Next is the oriented bounding boxes. For example, there you have the straight rectangles, but this is the oriented bounding boxes. So if it is a model trained for oriented direction, it will give you this rotated box. So therefore the result objects acts as a central hub, providing access to these different types of outputs with using easy to understand properties. So we can easily understand these things. So this is a one function written here. The main use case for the result object is to access the specific details of what the model predicted. So for example, the results can be obtained by using this function. So first you have to call this model, or you have to classify the model as a YOLO function. And let's see how to do this with a common example. This is for the object detection. Okay, when you run a detection model on an image, the results object it will get back and will contain like a boxes For example, there is a box. For example, you get this box, and from the boxes results dot boxes you will get the bounding box. And you can also print this found lane boxes objects as certain values. You can find the coordinates, you can find the confidence levels, you can also find the class. So so uh, we should run this model on an image. This model method will return the list of results, not just one. It will contain the many values, because it can process multiple sources or frame. For a single image also it provide the result, which is one of them or one item. So for example, results 0, results dot results 0 or something like that. If you call, then by the list, if you have the index 0, then it will only extract the first result, so that you can modify based on your need. So for example, here boxes, as I have talked before. So this is how you are going to access the detection bounding box data. This results has the dot boxes attribute, and if the model was not for detection, then it will provide result as a none. Okay. So this lane boxes, this boxes itself acts like a list or array of bounding box. So lane tells you how many were found. So if there are 3, 4 or 5 boxes, for example in this figure you can have 5 box. So next is this box with x, x, y, y coordinates, which will give you the coordinates and the confidence score as well as the class IDs as attentions like numpy arrays, but optimized for the device like a GPU. So we use this to list and item, this to list to get the standard Python numbers or list for printing. So this results dot names, this the results object also conveniently this it helps to store the dictionary mapping class. Like if you have ID, then to the class names strings it will map. So for example, if you are using the segmentation model like YOLO, ATN, segmentation, PT, seg.pt, so I think I have shown here. So for example, if you use this segmentation model, then the results object would have dot marks attribute. So for example, in the previous detection we have box, but here we have mask. So this shows the pattern, like access the relevant attribute, for example box or max or key points or probabilities or that orientations boxes on the result of objects. And then you can access the data unit from the resulting specialized object as well, like coordinates, confidence value, or the data, or these names and all. So let's look another section. So putting our results to work or visualizing and saving, we can see here. So for example, beside accessing the raw data, the results object provides super useful methods to immediately see or save the predictions drawn onto the original image. This is handled by the plot. So for example, we have this plot here. This plot method is used to get the annotated image. This will return the numpy array representing the image with prediction drawn on it. So basically it will be showing this type of result output. So let's look briefly here. So this annotated image NP, this results.plot, the plot method takes the original image data and the prediction data like a result box and the marks, and draws the prediction like boxes, marks and labels onto that image. And then later it will return the results as a numpy array in a like BGR format, which is common in computer vision. So BGR is like RGB format. So then the results.show. So we have results.show. This is the shortcut to display the image. So basically what it does is it is a convenience method built on plot. It helps to attempt to display the resulting image using the default viewer, useful in interactive environments or the simple script. So next is results.save, which helps to save as a file. For example, it is another convenience method. It calls the plot internally. It will call this same function internally and then save to the specified file path. These all methods make it incredibly easy to quickly visualize, also to share the model's output without writing any drawing code yourself. This plot method has arguments. It has arguments to, for example, customize what gets drawn. For example, if you can also hide the confidence score, you can also change the line thickness of those boxes and all. So basically, how it is working on inside. So when you are calling this model.predict, the predictor we discussed in chapter 5 component takes over, so it will start working. After it feeds the input data through the model's neural network, and it performs the task specific post processing. So like a non-maximum suppression for detection, all right, and it gathers all the relevant output data like coordinates, confidence scores, class id, marks, pixels, and all, and bundles them into the results object. So running the inference on the image data, raw model prediction tensors. So it will be doing all these tasks. You can see it here. The result object. The results object is designed to be flexible container. It stores a reference to the original image. So it has access to the original image as well. And the shape and performance timings, or like you can have speed. The class names like dictionary or names, and then optionally it holds the task specific output like box, marks, or certain for the segmentation or detection based on the need. This task specific objects like the boxes, marks, etc. are themselves objects that contain the actual prediction data, usually which are stored in the PyTorch tensors. These objects inherit from a common base class, which we discuss in a base tensor, which we have not discussed. Sorry, we have not discussed about the tensor there, which is outside our scope. But it it will these objects these objects like boxes, marks, they inherit from a common base class, which is base tensor, and which gives the common abilities like moving the data to CPU or converting to numpy arrays, or you can also move to GPU like CUDA. This make it easy to work with the prediction data regardless of the task. So the main code defining the result object and the task specific containers is also provided, or is also present in this GitHub repository. You can find inside the engine function or engine folder. So you can also see this basic structure. For example, what are different classes like base tensor, which hold the tensor like boxes, marks, etc., and provides the common methods like CPU, numpy, CUDA, 2 or 2. These methods to pass the result, whether what to do, or like they move the data to CPU or GPU. And these boxes, these functions, it holds the bounding box data for detection like properties, these properties, confidence as well as this clearing screen. I think this is so. And also max means segmentation. For example, what's the segmentation max, and properties like data and xy and xy, and this is the max pixels. These are the segmentation polygons, and these key points for the pose detection, and probabilities classification holding the probabilities, and for the oriented bounding boxes we have different values. And this results, this is the main container which holds everything, which is written by the our predict function. So there are different properties like .org dash image, which is the original image numpy array. Another is this names, it is the dictionary of our class names. Boxes include boxes objective detection model, this is for our max is for the segmentation model. And our key points, it's if it is a pose model, and the probes is used if it is a classification model, probabilities. And the OBB is if it is a OBB model. And this all others like plot is used to draw the results on image, or return the numpy array. So we'll display the plotted image, save will save the result, or the save the image, and save text is the saving the results to the text file. So these are all the things. So for example, this structure shows how this results ties everything together, giving you easy access to the specific type of prediction output via attributes. attributes like box, max, etc. This underlying data within the boxes of max is stored in tensors, inheriting common methods from the base tensor. So in this final chapter of the core concept tutorial, we explore the result abstraction. We learned that it is a structured report you receive from the AI model after it makes a prediction, containing all the findings like the bounding boxes, max, key points, and the probabilities. We saw how to access these different types of data using the attributes like a box or max, and how to easily visualize or shape the predictions using this plot, show, or the shape. So you have got these values here, methods. Understanding the result object is key to working with the output of your YOLO models and applying them into the real world applications. So thank you so much. This concludes our journey through the fundamental abstractions of the analytics framework. So we talk about the model, dataset, utilities, configuration, predictor, validator, trainer, and now results. So now I believe you now have a solid foundation to understand how these components work together to load, train, and validate and use AI models for various computer vision tasks. So to learn more, you can always explore the official Ultralytics or YOLO documentation, and you can dive into the specific tasks like object detection, segmentation, as per your need, or the look at the code files present there. So thank you so much for watching these videos. I hope that this is beneficial. Thank you so much. I will be bringing another important videos in the future. Have a good time.